Hey guys, welcome to Physics Vedika. So today we are discussing an interesting topic of motion. That's nothing but rest and motion. What is rest and what is motion? Right? It's a quite interesting question. When do you say an object is at rest? Or when do you say an object is under motion? This particular bus, a toy bus, okay, if I say with respect to me it is at rest, but if you observe this thing from the space, let's say you go to the space and observe it, somehow you are observing, okay, then what you observe, you can see that this particular house, it's rotating because the earth is rotating. Me myself also I am rotating, and this is also rotating. It means it is performing motion. But initially, with respect to me, this is at rest, right? This is at rest. But when you observe from the moon or when you observe from the space, what you observe there? You have observed that it is under motion. So just listen to these words carefully. Rest and motion are relative to each other, or you can say they depends upon the frame. If this toy is at rest, I can say simply this is at rest. But if you observe this thing from the space, everything is moving, right? You cannot fix something which is at rest, something which is moving. It everything depends upon the frame of reference. One more example. Let's say you are moving in a bus. There is a passenger who is sitting beside you. What do you feel? You feel like he is at rest, right? You feel like he is at rest. Somebody observes from outside. What he feels, your bus is moving. Means you are moving and the person who is beside you is also moving. It means that rest and motion are relative. Okay, they are relative. Means before asking a question whether an object is at rest or in motion, you have to fix your frame of reference. Frame of reference means generally the nearby surroundings you can keep as a frame of reference. If you want to observe, let's say if you want to observe the motion of this toy, what you can see here, right? Motion of this teddy, you can keep me as a reference, right? Or you can keep the surroundings as a reference, and you can say whether this teddy is moving or it is at rest, right? That is one example for frame of reference. You can keep the surroundings as the frame of reference. Generally in physics we will consider a mutually perpendicular axis like the x, y, z axis. Okay, this is nothing but this is called as coordinate system. Okay, so that is considered as a frame. When we generally solve physics questions, we will consider three mutually perpendicular axes, that is x-axis, y-axis and z-axis. System is considered as a frame of reference. So if a position of a body is changing with respect to time, okay, if it's changing its position, let's say this is a fixed point, okay, with respect to this point, if the position of a body is changing with respect to time, then you can say the body is moving, right? The body is moving or the body has traveled. Okay, you can say the body is not at rest. With respect to this frame of reference, if this body is not changing its position, you can see its position is not changing, right? So you can say that it is at rest. Position is not changing here. This lecture you can see its position is fixed. So you can say that at rest. Understand, right? So that is the thing about rest and motion. Is that clear? Hope it's clear, right? So regarding frame of reference, there are two types of frame of references. One is known as inertial frame and the other one is known as non-inertial frame, and these things we would be discussing when we go in depth into the motion concepts, right? So the next coming concepts are what is distance and what is displacement, right? So just watch all these videos, definitely you'll have a lot of fun and you'll also learn these physics concepts. I will make sure the physics will be your favorite subject. Tata, bye bye, see you.